Thanks to all of you that made it here. This is Data Science Dojo hosted meetup on online experimentation and A/B testing. Just for the sake of our record keeping, who was attending our meetup yesterday? Excellent. And who is here for the first time? Wow, we have a lot of first-comers. And who does online experimentation and A/B testing on a regular basis is actually practicing? We have one. Great. So we have a good mix of newcomers and as well as veterans. So a little bit about ourselves. So about Data Science Dojo. So we're a small startup. We have the founder, Raja, over there in the back. For any specific questions, I would defer to him. We're a small team focusing on teaching data science to anyone. We proudly believe that data science should be accessible and intelligible to anyone. So we offer week-long boot camps throughout the year in different locations. We've had over 3,000 professionals, over 500 companies represented in 10 different countries. The footprint for the Data Science Dojo is getting quite heavy. And yes, our mission once again is to make data science accessible to anyone. So data science for everyone. So if I'm going a little too technical, raise your hand, say too much jargon. If it's becoming too jargony, say please less. So here we go. So this is the agenda for the meetup. And again, it should be interactive. It should be, feel free to push back, ask any sort of difficult questions, easy questions. The point is just to make this time valuable for everyone. And yeah, once again, feel free to move around. There's pizza in the back, drinks as well. So a little bit about myself. I haven't introduced myself. My name is Artem Kopelev. I'm the data scientist here at the Data Science Dojo. My background is in healthcare analytics. So I kind of learned SAS as my first language. Did a lot of regression modeling, did a lot of unsupervised learning, cluster analysis. Particularly predictive models was basically what I had to do for a living. I previously worked for a health insurance agency. I worked for city government. I also did some consulting. So I got my feet wet in a lot of different spaces, and primarily thinking about how data science should be implemented, how a lot of people that I'm working for don't listen to enough evidence or actual data that is presented to them. I'm not pretty sure that's probably a common situation. So agenda for the evening. What is A/B testing? What are some interesting A/B tests? And then we'll go through some fundamentals of the terminology, the hypothesis testing, the metrics to measure the testing that we're actually implementing. Any questions so far? Awesome. All right, introduction. So in God we trust, all others must bring data. So I think that's particularly relevant in our world today, where evidence, where actual hard facts are needed at every conversation. It's not just about, this is what I think, this is what I believe. If you can, supplement things with actual hard facts and data. Anyone opposed? Do you listen to your heart? So what's interesting about A/B testing is that its background is actually in clinical trials. So in biomedical research, I don't know if anyone here is familiar, it's basically a case control study. So you look at what's currently being done, and then you think about, hey, what would happen if I just tweak this little thing or that little thing? What happens if I just experiment on something very small, very subtle? What about this intervention? What about this particular change in your diet? How does that affect the overall behavior or overall well-being of my patient? So A/B testing was picked up by marketers, or case control studies were picked up by marketers, and now it's basically online experimentation. It's prevalent everywhere. It's pick any big business, pick any big website, they're experimenting at all times. So how does it actually work? So we divide our clients or whoever's coming to our website into a case and a control subset, a randomized group. So randomly selected study group, that's going to be our case. So what could be the experiment? It could be something from, as simple as I'm just going to change the text here or make my click button a little bit larger, right? A different color. It could be a lot of things. So keeping all things constant, I'm just going to change one feature, right? That's my case. And for my control, it's the typical treatment. And once again, it's the randomly selected control group. And I'm keeping everything else constant. So does that make sense to everyone here? We can do an applied example. So what is A/B testing? So look at typical Google page. Let's just call this perhaps our control. And here's our case. We're just going to focus on the user interface right there in the corner. What if we change the color from green to orange? It could be something as subtle as that, right? So here's my A and here's my B test for my online experiment. There's the arrow. So what could changing just the color of the icon give us? Could it mean actually a higher click-through rate? Could it mean a lower bounce rate? Could it mean actually higher revenue per user? Something so subtle could actually have actual effects. This feels like a TED Talk, so you guys ask questions. I don't want to lecture the entire time. How many of you have heard about Obama's 2012 campaign? Yeah. I think he was a president at some point. Yeah. So what was exciting about the campaign is that it actually implemented A/B testing extensively. They've experimented on numerous versions of their signups and donations emails just to see what could drive more and more engagement, right? So in the first situation, what differences can you spot, right? What happens? What are they trying?
The text, changing the font. No, yeah.
There you go. Trying a life-size picture, rearranging different text. Are you in? 2012 starts here. So each iteration was essentially an A/B test. They were seeing, hey, is this increasing our signups? Is it actually increasing our donations? You're not convinced? So these are just practical examples of how A/B testing has been with us for quite a while. So there's A/B testing that's done on newsletters and email. Essentially, some group gets subject line A, another group gets subject line B, and we see what are the different rates of response. Run tests, you can run them on many things. Yes?
Can you run multiple A/B tests at the same time?
Absolutely, you're getting to the we'll get to it in a bit, yeah. And we'll talk about why maybe A/B testing is better because you just incrementally test one thing at a time, or you can actually do a number of variants right away. So you can look at your subject lines, you can look at the from names, you can look at the send dates. So there's a bunch of options. So we can also, let's see, so how many of you would say version A is going to be more effective than version B? So which button do you think works better, the green button or the red button? Let's see, how many would say version A? 2, 3, 4. How many would say version B? Which button increased the number of clicks? The red button by 21%. See, without A/B testing, our intuition might betray us. Testing the navigation bar. So should we use why use us or how it works? How many of you would say version A? Nobody. Version B? Almost everybody. And which experienced increased clicks by 47.7%. How it works, version B. So why did you guys guess right on that one? What makes you think? Thank you. That was brilliant.
That's
Welcome.
what I see,
Yeah, yeah. So that was a great point there. So it's framed from the perspective of the person looking at it. So you should always be thinking about how is my user interfacing? How is my user potentially connecting to the experience in a way that's a lot easier, right? In a way that's a lot more reasonable for them. How about this? So if we have Jocelyn and we have Michael. So this is a questionable A/B test just because there's so many other features. It's not just Jocelyn and Michael. But who gave us a better conversion rate? How many of you would say Jocelyn? And who would say Michael? About even. It turns out Michael increased conversions by 21%. Was that counterintuitive? So yeah, this is why we experiment. Here's another example. Mobile notifications for priority messages. Let us find your urgent messages, or get away from your inbox, let urgent emails cut through the clutter and find you instantly. Version A or version B? So which version increased signups by 38%? Who would say version A? We have majority for version B, or majority for version A, and it's actually version B. A longer yet clearer message is more effective in this situation. It's counterintuitive, but this is exactly why we experiment.
Well, how about the font?
How about the font? Exactly. So there's another difference. There's a bold. So there were a lot more factors than we were just talking about here. Basically, this was a summarize on this online form. Which redesigned form increased business-to-business leads by 368%? How many of you would say version A? And how many would say version B? I'm assuming the rest. Version A.
Oh, well.
Why do we think it was the case?
Check boxes instead of free text.
Check boxes are easier. That's That's a great point. Yeah, so there's something, just a lot more simplified interface in terms of the select one. So this is also not necessarily an A/B test. There were other features introduced. Here's another one. Which version increased leads by 115%? For the which California closet layout of the website? You've arrived, or clean, bright, organized? How many would say version A? And version B? Almost everybody says version B. Version A, once again. This is why you should test. Every time we think we got it intuitively, it's not necessarily the case. All right, so the fundamentals of A/B testing. We just went through a bunch of examples, kind of proving the point that our intuition may often fail us. So we look to data scientists to do some A/B testing for us. Once again, why do we use A/B testing? Users are complex, and our intuition could be wrong. What is the purpose? We get to know what the users actually want, perhaps unconsciously or just otherwise. Rolling out a feature to all the users at the same time could be risky. So if you're a part of a big, large organization, you'll want to experiment as many times as as resources allow before implementing and deploying to the to the entire product line. It helps us fail fast and move on. So if we want to try a different color button, if we want to try a different text, if we want to try a different design, any small implementation, it helps to experiment and fail fast. I think this is common sense. Impact is always expected to be positive, but oftentimes it might not be. Yeah, so it could be humbling. You thought this could be something brilliant. and make a lot of money. At the same time, it happens that nothing really changes. And you're back to the, step one. All right, so this is what the question was about, multivariate testing, right? So we can also try to, perhaps because our resources are limited, because we know exactly the versions that we want to try, we can also attempt multivariate testing. So instead of a binary implementation of the same feature, we're doing variations. This could be the right approach in some situations. So let's look at this. So for dual, right, we would compare two different designs. For multivariate, it could be different variations, combinations, permutations of the features that we want. This becomes hard to track and manage. And because there could be so many different permutations or combinations, this might not be preferred for your business. So once again, it's whatever your business thinks is the most relevant, whatever the business finds right. So before you even undertake this, a lot of time you just need to think about, am I answering the right questions? Am I actually addressing the right business problem? So with A/B testing, it's easy to implement and actually test, experiment, like a solution to the problem. But remember that the business problem that you pick in the beginning will actually drive the entire journey that we have right now. So when you get to this point, is it A/B testing or is it multivariate testing that we should try? Consider the advantages, consider the limitations. The advantages could be that it's simple in design, that it could be something easy to experiment with, to explain, to track. Right, you do this in series. You try these two variations, then the next two, step back, that didn't work, next two. And it's one limitation is that you're going rather slowly. You're only trying one alternative at a time. Any questions? Am I going too fast? Am I going too slow? Yes.
So, are you supposed to be doing your A/B tests exactly to all of your users? When you for example, you have a case and control group, you have 100 users, let's say. Are you going to randomly select only 50 people, or
That's a great question. So let me just repeat it. So the question is basically about sample size. For our experimentation, how much of a sample do we need to really prove the point? And my answer would be it depends. So it'll depend on the business question. It'll depend on the impact. It'll depend on the services that you're using. If you're not actually implementing your own kind of statistical package or vendor, basically, let's revisit it again. So we'll see it with some math later. Any other questions? Yes.
You're just trying to, maybe it's an academic question, but trying to understand how you separate these two in terms of when you say different combinations, a lot of different combinations, are you referring to within the variants or different variants? So for example, A/B testing, in this case, it's two different, are you saying it's two
Right.
variants, so there's control and variants
So
within that one chain?
right.
Or are you looking at multivariate in terms of multiple changes between control and variant?
So the complexity that you pick will be up to you. What we would recommend, right, is focusing on just one feature and seeing all the different variations that you think you would want to implement. The problem is that with multivariate testing, we wouldn't know the interactions, right? So let's say, so does it make sense? You can just say color of the button, right? It could be yellow, orange, blue, red, green. I'm going to try all of those, and because I have enough users, because I have enough visitors to my site, I'm going to send 500 that way, 500 this way, 500 this way, and see which one is actually giving me better click-through rates. So this is the idea behind multivariate testing. It could become even more complex. It could become not just the color, but also the size, and then I'm doing all those permutations. So Thank you. You had a question? Yeah.
How do you keep other parameters fixed or constant? So let's say you were showing examples of Obama's side redesign now, or let's say some new scale, and suddenly somebody is starting to make, or people are starting to make a noise, or maybe Amazon is trying something, but the third party sellers drop the price. So how do you actually control those parameters which are not actually under our control?
Interesting. So that's a great point. So in our lives, there's going to be so many variations or events that are not necessarily constant, right? Is your point. Um, so this is exactly why randomized samples are so important for both our control and our case subgroups, right? For our study group and our control group, we're going to make sure that we're randomly selecting folks, our users, they're being randomly collected. Because that way, we can assume that that population has experienced all those other, because we're drawing them from the same bag, we can assume that they've all saw some sort of Barack Obama speech or some sort of, right? So all of the events are also inherent in our sample space, if I could use that language. Yes?
Sort of an anecdote about that too. I was doing some A/B testing when I worked at YouTube, and we had time variance. Like people use YouTube really differently on the weekends and during the week. So
Right.
we run a test of running from like Monday till the next like Sunday night, so you make sure that any time variation is handled. But the more of this you think of, the more worry you have about it, I guess.
That's exciting. Yeah, that's brilliant. And I think people don't think about time enough. You want to make sure that you're possibly sampling at the same time frame, right? This is also very interesting because, yeah, my response to a red button might be different from my Wednesdays or Mondays than on a Friday or a Saturday. I might be a lot more relaxed or something. It's a great point. So there's a lot of potential factors that could influence conversion rate, click rate, that we presume are equalized when we randomly sample. It's a big assumption. And we also assume that they're going to be normally distributed. Or there's a lot of statistical conversations that we can also have there.
Selection bias, basically.
Is there? Yeah, we're avoiding selection bias. Any other questions on this? So bigger sample size is needed for multivariate testing. Yes.
In the case of multivariate testing, are we going to have just one control group, or we need to have control group that only varies in one feature?
Right. So basically, you're taking just what you have right now. Let's say it's a green button, and I'm going to try orange, yellow, just all sorts of different colors. But does that make sense?
I think I'm talking about different scenario then. In the case that we want to try 3 different colors and 3 different fonts all at the same time. So we have 9 different
We have 9
combinations.
options, right?
So the control group now is the same for them, no change, or we have to make the control group the way that only changes in one of those variants.
So this is one example of when the experimentation could get as complex as you'd like. The best comparisons would be your control and the current experience, and then all your new potential experiences could be lined up, and you can argue that they're going to be comparable, right?
In this case, we would have
15 different cases,
Yeah, one control.
and just one control group.
9 for the 9 3 times 3, and one group for 3 different fonts, one group for another 3 for the 3 colors.
So you mean that you would have different control groups and not only one?
You also want to look at not changing the color or not changing
Yeah.
So I
Exactly.
would set up 15
Experiments,
experiments and a control group.
right?
Yeah.
Yeah, you always need that reference. You always need that reference situation, basically the baseline, right? So in clinical trials, you think about what's my baseline, what happens if I don't do anything, and then here's what happens when I start doing something, when I'm changing the button, when I'm changing the text, if I'm starting to insert different images. This is just more and more features that I'm adding to something that I need to keep track of. And that's why most companies will prefer just straight A/B testing, because it's just doing something in series. Oh, this increased it, good. Next experiment, this increased it, or this decreased it. Okay, don't try that, try something else. I mean, what's great about it is that it's easy to revert to, right? You're just, okay, the current experience is working, don't break something that is already working. So it lets you incrementally build to get the best effectiveness. All right, so let's talk about some terminology. So once again, control is the default experience, the way that things are now. Treatment is the change we would like to see or we'd like to try. Here's an example. Here's my current look. It's a green button, buy now. And there's my treatment. If we want to try a blue button that says buy now. So changing from green to blue. Here's a quick illustration. What we're doing is, out of the 100 people, randomly select 50 of those to be in our green button and 50 of those to be in our blue button. So we're going to talk about some metrics. So what are some of the metrics that are used in online experimentation? It could be anything from queries per unique user. It could be session length, sessions per unique user, page views, bounce rate. Can others think of other metrics that could be useful? Seasoned veterans, what is it that you typically look at? So for online retailers, it could be conversion rate, revenue per unique user, average cart value, and others like that. Right, so once we decided on, this is the business question that we're addressing, what is the best metric to really focus on, right? Because if I'm going to implement 50, 100 A/B tests, I want to concentrate on something that really matters to my business. And what could that be, right? It could be something like session length. It could be page views. What is really driving the revenue? What is really driving the lifeblood of the business? I think it makes sense, right? Can anyone else think of other things that could be useful in terms of metrics?
I guess in case of email campaigns, it can be clicks versus open, or like
Makes sense, clicks. Anyone else?
Spending more time.
So it's basically the session length kind of idea. Click-through rate.
How much money they pay?
How much money they pay, that's a great one. So actual dollar figures. So not just the average cart value, but it could be average purchase amount. So these are all things that should be, and you can argue that these metrics are also, some are more primary, some are more secondary, some are, right, at some point of the business cycle, they're going to be earlier than later. So it's going to be very important that you focus on the right metrics that matter for these A/B tests. Otherwise, you might be wasting time and actually not getting the results that you're hoping for, right? Maybe color changes to a button is not. It might help with session length. It might help with maybe conversion rate. But then, is it influencing other things like average cart value or something like that? Yeah.
What does this CTR mean?
It's the click-through rate. Click-through, yeah. So sign-ups for newsletters, as we talked about, the Obama campaign. So each business is different. So make sure to consider and review the metrics closely, because they actually driving so much of our own time and our own interests and work. Yeah.
Is it expensive to measure all of those?
Is it expensive to measure all of those? I mean, it depends on your business.
If it's not expensive,
Then go for it.
set up some automatic
Yeah, absolutely. I mean, I would just caution against having like hundreds and hundreds of metrics that you're looking at, because then you're, without assigning magnitude to them, you might get just lost in terms of if you're actually a manager and you're thinking about this is what's driving my business, but then if you build me a dashboard with thousands of metrics and you're saying, oh wait, this A/B test shows that we've improved on those 5 metrics, but actually decreased on these 5 metrics. The point is you have to be efficient, you have to be frugal. Parsimonious is a term in biology. You just try to get the most practical solution with the least amount of metrics. Yeah.
Do we have to assign same number to to each group? Sometimes it's risky. We want just to assign smaller.
A smaller group.
What's that?
So I think that's a question for a more advanced class in statistics. Basically, what's going to be representative, right? Your question is, and that's what you learned yesterday at the meetup, what's a representative sample? Is it big enough to be representative? And was it randomly assigned? If so, right, yeah, you might only need 200, 300 of your customers to look at something. And you can say, I applied a few statistical tests, this should be enough. So there's the vendors that do A/B testing, they will provide you sample size calculators, they will provide you with tools to help you decide, was this enough? Because it doesn't have to be equal numbers. It could be something smaller. It could be, let's say it's actually expensive or risky, and you want to minimize those risks. So what are we talking about? So this is basically hypothesis testing, right? Is my intervention somehow different from my control? So the null hypothesis, control and treatment are similar. There's no difference in the user experience whether I use a green button or a red button. Control and treatment are similar in terms of the parameter that we're estimating. So this is really important. This is just back to how metrics will really drive our decision making. Make sure that we're focusing on the right metrics, the right parameter, and then we're doing the hypothesis test. So if anyone remembers their statistics class, basically there's a null hypothesis and there's an alternative hypothesis. Treatment is different from the control, is our alternative. That there's some magnitude difference between them, and that is what drives the business, right? That's why we keep doing more and more A/B tests. We're looking for ways where the control and treatment are not the same. So here's that same example. So the null hypothesis would be green and blue buttons have the same click-through rate, whereas the alternate hypothesis would be each button has a different click-through rate. Yes?
With what confidence you can say that the null hypothesis was incorrect?
Right.
Is that what the tool will help us do?
So, right. So typically the online vendor will help you. Your friendly statistician will help you. We're not going to get into this in this talk, but hypothesis testing basically is, what is a confidence interval? Am I doing one tail, two tail test? Am I doing a comparison of two means? So those are all great questions for the boot camp, actually, if you would like to take it, if you haven't. How many actually here attended the Data Science Dojo boot camp? We just have a few. All right, great. Yeah, so this is also a repeat of some of the things that you've seen during the boot camp. We're basically talking about that online experimentation exists and has been existing for a while. It's constantly going on. Most of us are unaware that we're actually being, in the control group or in the intervention group. There's basically, if you're an online business, you have to keep doing this, because that is the way that you survive, and that is the way that you find new profits, that you find new customers, and so on. Yeah.
Can there be a scenario where, let's say, the CTR is same for green and blue buttons, but after some time it increased for blue button rather than green? So, like there was a latent period, and then basically it moved in the alternate.
Anything is possible. Absolutely. It's a great point that time could really, nothing is static, right? So time could really play a role.
So does it mean that we started with something, changed something which did not produce and then go back?
Absolutely, you can always make it a circular exercise, and that's another great thing is that it should not be just a one-off. I'm saying make sure that if this is a business problem that really matters to your business, make sure that you're retesting. Make sure that you're taking that sample showed me a 34% increase. Let's try it again next week, because if I'm going to implement something into production, I better be sure, because it might be a risky endeavor. It might be something that really going to implement my bottom line, affect my bottom line or my customer retention. So retesting is a huge piece of this. And not very many businesses do this enough. Actually retest the findings that you find on the first run. I think, if we see something positive, we try to run to it, and then we didn't actually give it due diligence and testing it. Let's try a different, so it's not necessarily an A-B test at that point, it's an AA test. You're checking that sample and this sample and this sample and this sample are giving me the same parameter estimate, or the same impact, right? The same, it's a 34% increase on click-through rate, and I'm seeing it over and over again. So we're going to talk about type 1 and type 2 errors. So if you remember, hypothesis testing basically means that I could be presuming that I'm right, and I am actually right. So that would be a correct decision right there. Or I can be presuming that I'm wrong, and I'm actually not wrong. So that's what the correct decision is here. So basically, there are two types that I can be wrong. I can think that, no, there is no difference between the blue button and the red button, but there actually was. So that's my type 1 error. Or I can think, no, there is a difference, but there actually isn't. That's my type 2 error. We're good? For some of you, I know it's really basic. And for many, this is basically the confusion matrix. So it just reminds them of how confusing this can get. So how do we avoid types of errors, like these types of errors? Is basically retesting. You rerun and you retry it on a different sample. You review it, and we can actually, let's do some analogies. There's some good examples here. So basically, there is no fire is my null hypothesis, and then there is a fire is the alternative hypothesis. We're going to look at a smoke detector. So there are times when there is no fire, but the smoke detector will go off. Has anybody ever had that happen to them? All the time. Just something is, you're making tea and it suddenly just goes off. That's the type 1 error. So basically, my model or my estimate thinks that they've detected some sort of a change, but there actually isn't anything. So the cook removes the alarm to prevent type 1 errors. And guess what happens? It increases the chance of a type 2 error, where there is actually a fire, but the alarm is not going off. Right? So there is some sort of a smoke, but the alarm is not sensitive enough to pick it up. How about this one? The boy who cried wolf. Has anybody heard of this story? It's like a common children's tale reminding us that be careful with when you start crying wolf, when you start detecting, oh no, it's a wolf. So basically, the kid just pretended that there was a wolf and told everybody in the town that, hey, there is a wolf. He's committing, or we're committing a type 1 error. Here it is. Villagers believe the boy when there is no actual wolf. So what happens then? Nobody believes this kid the next time he's coming to say something. It's a type 2 error, right? So we are so oblivious to any wolves that the wolf might actually show up, and the only one who's seeing it is the boy, but we don't believe him. So let's add some math. So this is what we talked about a little bit, and this is the confidence intervals. So basically, in hypothesis testing, you're checking whether you're within a certain interval to be either is it a significant change or is it not a significant change. So here's an example. On a 5-point scale, a product has an average rating of 4.32 and a standard deviation of 0.845 based on 62 ratings. What is the 95% confidence interval? If anybody's able to do that in their heads, it's pretty impressive. So the formula is we're taking our average plus or minus 2. This comes from the z-score, or 1.96 if we want to be 95% accurate, 95% confident, multiplied by our standard deviation divided by the square root of the sample size. Once again, I know it's really boring to some of you, but this is how we get to the confidence interval. And what does that actually mean? That means 95% of the time, my mean value will fall within this range, right? So if that value is greater than the current, right, my current implementation of the red button, then I'm pretty sure, 95% sure, that there was a significant improvement in the click-through rate or whatever it was with my new button. Mean, standard deviation, sample size. And that's the critical value. The critical value comes from, well, I think we'll get to it in a sec. So once again, here's how we can work it out. So if the mean is 4.32, if the standard deviation is 0.845, standard error is going to be 0.845 divided by square root of our sample size. So 0.845 divided by square root of 62, we get 0.11. Margin of error is basically our z-score times the standard error, so 0.22, and the confidence interval is from 4.1 to 4.54. We good so far? Just a little bit of math at the end of your day. I'm sure it's refreshing. So once again, so we are 95% confident that the average review for all of our customers is going to lie between 4.1 and 4.54. Any questions here? We're good? So we can talk about the intuition. So if we know for sure that the average product review for all customers is 4.4, and so we know this is going to be the mean, when we take 20 random samples, because we're 95% confident, one of them might be outside of this range on average, right? So if I'm retesting, we have to remember that there is always a possibility, 1 in 20 chance, because we're 95% confident, that one of those means will be outside of that range, right? So the point is we have to get used to some uncertainty. Even when you're 95% confident, there's 1 in 20 chance that I might get a type 1 error, type 2 error, right? So this is the point. Let's see, I think I'll skip that. Here's some more examples around the confidence interval. So anywhere for our large, if we have very large sample sizes, we can just use those z-scores. So for 95%, it's about 1.96. To be 90% confident, it's 1.64. Essentially, if we want to become more and more confident, we're going to spread out our interval more and more. If I want to tell you I'm 100% confident that it's going to rain tomorrow, what am I going to say? Well, that's a bad example. I'm 100% confident that the temperature will be from -20 to, 99. So if I give you a wildly wide enough range, I can say I'm 100% confident. With less confidence, we're going to have to experience more uncertainty. Yes, question.
One of the sort of ongoing public policy issues around scientific research is reproducibility of results. And I'm thinking specifically of medical research in which, a study says that eating broccoli causes cancer, and then somebody else tries to reproduce it, and eating broccoli does not cause cancer.
Right.
And so there's, a question as to whether 95% should be the confidence confidence interval, or whether it should be higher. Do you have any thoughts on this? How do you evaluate 95% versus 99%?
Sure. So that's a great point. So there's certainly arbitrary values. They've been kind of established in the field as the rules of thumb. I'm not, in terms of reproducibility of results and experiments, I would argue that it's not necessarily that's where the focus should be on. It's where the methodologies are just so divergent. And people, or at least in academia, there's not enough transparency of this is how the experiment was set up, this is the methodology that was prepared. So few of these experiments actually become not reproducible because of whatever was convenient, this is what was done, or whatever statistic was most available, this is what was done. And so you see that in an industry where publication is actually your revenue generator, you're going to throw out a lot of studies that are perhaps not as robust, not as well tested as they should be. But yeah, 95% confidence just reminds you, it's just that 1 out of 20 chance that it'll be completely out of that interval. But yeah, we can have a whole long conversation about this topic though, if you want to take it offline. And p-values and how much we've obsessed about, is it statistically significant? Is it statistically significant? Even if it is statistically significant, it doesn't mean that it's, first of all, likely. It might actually be, well, yeah. Let's talk about that offline. Sounds good. Any other questions? Yeah.
So now we are changing a lot in terms of we're getting more personalization, moving more towards personalization, and we're getting more data for each individual from Netflix to Amazon shopping cart.
Yeah.
What a particular user is like, and they do a profiling in the back end. How does A/B testing changes, or what is the difference between targeting a mass A/B testing versus more personalized A/B testing? For example, say I'm doing A/B testing for a particular profile, or say just for you.
Yeah.
Do you like more video contents, or do you like more text contents? Are you more like a person who will download the stuff?
That's a great question. So in that scenario, so the question is, if we start A/B testing on individuals instead of groups, what happens? So in those situations, the experiment is treated as my control is going to be, let's say, my past, and I'm going to say, my week, I don't know, a year ago. So these get messy, right? Because you're presuming that you have a control, like my personal preferences that were maybe a year ago, and now you're going to check, if something that you're doing differently is affecting or if I like something. So that's another great long conversation about how to best design and structure very personalized A/B tests. And do I need consent for some of these things? Right? So Facebook got in trouble, I'm sure, as everybody heard. What if we're starting to only give some sort of slightly negative information in their news feeds? So they got in a lot of trouble for this because there's some ethics involved, because you didn't have the consent, you did not have maybe the full right to only feed a certain perspective, a certain side of news stories around the world. So yeah, that's a very big emerging topic. I'm glad you brought it up. Other question you had?
So can there be a scenario where basically after certain confidence level, let's say 90%, if you increase it to 95%, the business question which you are trying to answer grows exponentially. However, from 95 to 97 or 99, there is a law of diminishing returns. Like it's not growing, it's just linear, not exponential returns and all. So you stay at 95% confidence level straight line.
That sounds right. I mean, there will certainly be a diminishing return when you try to, what is going to be practical, right? If you want a 99% interval, that means your range is going to become so wide. What could help is just taking even larger and larger and larger samples, right? If you want to be very sure, you're not only retesting, but you're also taking bigger samples. And that way you can say, for this product, I've tested it, there's a large enough sample that I am even 99% confident that it's going to fall between this tiny range. So you know, we focus on the things that we can control, and we also think about what costs more and what costs less. Does that answer your question?
Yeah. So what I was trying to ask is, there is no, like, maybe there is no one confidence level or like silver bullet for the confidence level.
Right.
For some business questions, even 70% might give you the business returns or business goals.
Absolutely, and it should most likely be hierarchical. You should have some sort of a first model to assess things, then the next model, then the next, right? As in, yeah, you look at one metric first, and then you maybe want to look at another metric first, and you're thinking about which one answers the business question best, right? Some sort of like a hierarchy criteria. For our example, it was right there. So confidence interval. So once again, it's the range of plausible values of a parameter being estimated given a sample data. Here's a great example with Garfield, right? So in terms of weather, taking a look at tomorrow's weather, the high temperature will be between 40 below zero and 0 or 200 above. This guy is never wrong, right? Because he's providing basically the entire sample set, the entire potential temperature they can be. And we talked about this already. So the AA test is essentially, I'm rechecking and I'm reevaluating that the sampled cohort is representative and it was something that didn't happen by chance, that there was no skewed or some sort of biased representation. So these are very important and once again, not done enough. And they should be for business questions that really matter. So we're comparing the identical experience on different random sets of users. It's used for validation. So we're going to try the green button and the green button again. And just checking and then checking that there's no other variation. So let's focus on this slide. So this is exactly what we're talking about. In A/B testing, it's all about the business question that you're really concentrating on answering. And then how are you designing the setup of the experimentation? First we plan, we choose factors, levels. So factors are the features, right? The features that we're focusing on. The levels are maybe just different colors of that feature, of that button. Then what business questions that we're trying to answer, and then the metrics and the expected outcomes. So we really think about, we build our hypothesis ahead of time. What kind of coding and logging would require. We want to make sure that we document every step, just in case we need to step backwards later or see where the biggest increases actually occurred. We do an AA test to make sure that the setup is already balanced, that there's no difference in my first randomized cohort and another randomized cohort. That all of the other features are basically equalized, right? So if there was some sort of an event, some sort of a wild event, that it's uniformly distributed, right, for my entire potentially sampled group. So then we decide whether A/B or multivariate testing is more appropriate. Is it something binary? Is it just the changing of the color of a button? Or is it something like, let's try out all these different buttons, let's try also different text. So there's a lot of potential implementations here, given the resources, given the amount of time. Most would advise to keep it simple, or it depends also what vendor you're using. Google Analytics, 5-second test. There's a 5-minute test. There's a bunch of options. So then there's analysis interpretation. Sometimes this can be an art, right? So is there seasonality, right? Is there a newness effect? It's like, oh, this is so exciting. This button is just blowing my mind. It's so ridiculously cool. And then a week later, what was I thinking? That button really did nothing. So we have to be really careful, and you want to trial and test as much as allowed for your business. And then make a decision to ship or not to ship, or to deploy or not to deploy. So yeah, you want to make sure you covered all the steps carefully before getting to that point, especially if you're Amazon or Facebook or any very big, high impact organization. So here's some categories of metrics. There could be some that are more short term. There could be some that are medium term. Some could be longer term. And what happens if they're in opposition to one another? What happens if I get a lot of quick wins, but then I might actually lose some customers later on? These are, what do I want to measure? Do I want to invest and I want to make sure that I get loyal customers, or do I want to just squeeze as much money as I can out of them now? So there's a lot of these questions as well, and that's all dependent on your business. Think about them carefully. Come talk to somebody at the Data Science Dojo. Maybe they can help you figure it out. So here we go. Here's some A/B testing tools. So a lot of people might use Google Analytics, Optimizely, Unbounce. Okay, so they essentially just give you an add-on and do the A/B testing for you, and you can test and test and test and test to submission. Whatever you'd like to vary, and hopefully it'll bring a lot of great results to your organization. Any questions? I think we kind of blazed through that. Yeah.
I'm not sure if it's a statistical question because I'm not from that background. But
Yeah.
say for example, if 100 people are your complete set, and you experiment something, some A/B testing, and you send out something to 100 people, but only 20 open or actually interacted with your test,
Right.
but 80 didn't even touch it, totally ignored it. Out of 20, you get some insights and you say, this is my insight and I'm going to use it. How do you deal with those kind of scenarios? Because 80 people actually did it,
Right. Right. So that is a question for offline and stats question essentially. You'll do probably a two mean estimation. So yeah, I would have to think on that further. And those vendors essentially do those things for you, right? They provide you with the sample size that you might need. This is what you probably should go for, because only 10-20% of them will open it, compared to our control, where the engagement is about 10 to 20%, something like this. So if it's a representative sample, if it's comparable to something that's already happening with the control group, you might be fine. So that's a good question. Other questions? Yeah.
So you talk about the retest. So what's the time frame, to the retest? I think I know it's case by case.
Right. Depends on the business.
It depends on different scenarios. It's like has time varies, time theory, because time change maybe the base for your group.
Right.
Target the distribution has changed. So could you give us like a example for your during the course or your career, like what time frame?
Yeah. Well, I mean, I would defer to someone practicing, maybe our visitor from Microsoft. He can chime in. It's what happens when it's seasonal. Do you check it on every Saturday, or do you check it? What would be the best practice?
I mean, in that case, we ended up just running. We were worried that things would change over a month, and like the one big A/B test they run. I mean, we were worried about different days in the week, and we ended up running it for like a month, just to sort of see that the different weeks were about the same. We didn't do anything super sophisticated about that. We just sort of let the thing run for a month and made sure the start and end times were at the exact start or end of the week.
Got it.
Seemed reasonable.
So it depends on your business.
I know that in retail they have calendars that they go with that every year. For example, they have a period that this is Thanksgiving period. This is this event or this specific season.
Yeah.
And they compare it with last year.
Last year, so.
Same period.
Yeah, and as long as those years are comparable, we can say
Yeah, it's not working
it's also
perfectly.
yeah.
That's all they have.
It makes sense. Yeah. Any other questions? Well, thank you guys so much for the privilege to talk to you guys. We hope to see you again on behalf of the entire Data Science Dojo team. Thanks, guys.